In this video, we'll determine the behavior of a polynomial. Here, this polynomial 2x to the fourth minus 4x cubed minus 2x squared plus 13x plus 12 near plus or minus infinity. And that's saying as x gets really big, how is this polynomial behaving as x gets really big in the positive direction and as x gets really big in the negative direction. And let me show you how to do these. These are tricky until you see one or two of them. So you take p of x and you factor out this biggest term here, 2x to the fourth. Factor that thing out. That is, you take 2x to the fourth, pull it out of every term in there. So what would I multiply back to get 2x to the fourth? I need to just multiply by 1. Okay, I need to multiply back and get a negative 4x cubed. So what's that going to be? A negative 2 over x. Right, so 2 times 2 is going to be 4, and x to the fourth divided by x is going to give me the x cubed. Plus, I need to get 13 halves. I need to get 13x back. So I'm going to multiply by 13 over 2, and I just need an x when I'm done, so I need x cubed down here. So that takes care of that term. And let's see, so I lost this negative 2x term here, so let's put that in. I need to multiply back and get a negative 2x squared. So 1 on top, and what's going to go on the bottom? X squared, because the x squared is going to take away the 4. We'll talk about this again when we get done here. So I need to get a 12 back. So how am I going to get a 12 back? Just multiply by 12 over 2x to the fourth. Okay? So again, let's make sure we know what we're doing here. When we pull out the 2x to the fourth, I'm trying to find something such that when I multiply back 2x to the fourth minus 1, I get that 2x to the fourth back. When I multiply times that term, I get 2 times 2 is 4, a negative 4, and x goes into x to the fourth 3 times, so that gives me the negative 4x cubed. And for the 2x squared, I skipped that one, so that one's there. So 2 times 1 gives me the 2. The x squared goes in to the x to the fourth 2 times, so it gives me negative 2x squared. And for the 13x, it's going to be this one. When I multiply, the 2's cancel and leaves me with the 13 on top. The x cubed goes into the x to the fourth and leaves me with just an x, so that gives me my 13x. And then for my constant here, I need to multiply and get 12. So when I multiply, the 2x distributes out here. The 2x to the fourth cancels each other and just leaves me with 12. So I have factored the 2x to the fourth out correctly. And what we notice here is that as, let me write this down. Note that as x gets really big, these terms go to 0. Oops. Go to 0. And when I say these, let's say we're talking about the terms in this purple color here. These terms. That is, this term goes to 0. 2 divided by x goes to 0 as x hits. That is 2 divided by 100 million is a really, really small number. That is, it's going to 0. So, and now we look at 13 divided by 2x cubed. As x gets really big, that goes to 0. So as x is really big, it's not contributing to this polynomial very much. Here, as x gets really big, that term goes to 0. It's not going to contribute very much. As x gets really, really big, that term is going to go to 0 and it's not going to contribute very much. Therefore, note it doesn't matter in the positive or negative x direction. This is going to stay the same because it's x to the fourth, whether it's positive or negative. These are all going to go to 0. They're either going to be close to 0 on the negative side or close to 0 on the positive side, but they're all going to be close to 0. So they're not going to contribute very much. Therefore, near plus or minus infinity, p of x is approximately equal to the only thing that's left here, 2x to the fourth, because everything else goes to 0, and so 2x to the fourth times 1 leaves me with just 2x to the fourth. In calculus, you're going to write this as the limit as x goes to plus or minus infinity of p of x equals 2x to the fourth. Now, if you want to use that language now, I'm fine with that, but you don't have to. You just need to know that this is what it means. But again, if you want to say it in this manner, I'm fine with that, but you don't have to. So, what that really means is that in the long term, in the long run behavior, the only thing that matters is this 2x to the fourth out here. And so to show this graphically, I've got a couple pictures here that I want to show you. So here in blue, there, that's the polynomial, that's p of x, that's the crazy one. Okay? And in red, we have, what was it, just 2x to the fourth. So this is going to be f of x equals 2x to the fourth. And looking at them right here, you see there's a lot of space. There's a lot of space between them. They look like they might be kind of different functions because we're zoomed in on it really close. But let's go and look at another picture here. Note here that my domain was from -3 to 3. Now here I've got another graph where I took the domain from -10 to 10. And you see that as we zoom out, there are differences in here. That was in this region here. Those differences, as we zoom out, start to disappear, but we still see a gap here. Okay? So now from -10 to 10. But now let's go to, I changed my domain from -100 to 100. And you see here that they start to just look like the same graph. That is, red and blue makes purple. And they look like, if you zoom out far enough, they start to look like the exact same graph. Okay? And what we get that any polynomial, p of x equals a1 x to the n plus a2 x to the n minus 1 plus a3 x to the n minus 2 plus dot dot dot. No matter how many you have, this thing eventually, if you zoom out far enough, if you go out toward infinity far enough on either side, it's eventually going to behave like that biggest term there. It behaves like the highest power and its coefficient. Okay? So again, to recap here, we have this polynomial p of x here, and we're going to look at what happens to it in its long term. And we do this process here of factoring out that highest term, and then looked at what, and it's clearer then what happens as x goes to infinity. These terms all go away. They go to 0 and they disappear. Okay? And then, so what we're left with is simply this term times 1, because when you distribute to these terms, those terms are going to be times 0, or times something really, 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 really close to 0. And so it makes no contribution. So it behaves like 2x to the fourth. Thank you.